Hello, this is Professor Broker, and this is your Chapter 5 lecture for Econ 231 about elasticity, Part 1. Let's go ahead and get started. So I want to put you in a scenario with some price increases, and I want you to think about how you might respond. So imagine this sign was on your favorite pizza place. Due to an increase in the cost of cheese, all items on the menu have been doubled in price from $2 to $4. So say a slice of pizza has gone from $2 a slice to $4 a slice. Okay, how might this impact your buying habits? Specifically today, you walk in expecting to pay $2. Now you're going to have to pay $4. How might that impact your buying of pizza from that establishment versus you're on empty. You pull into the gas station. Gas is, you're used to it being $2 a gallon, give or take, and now it's $4 a gallon. Okay, how would this impact your buying habits today and also even in the immediate future? Okay, my guess is that for most people, their consumption of gasoline wouldn't change that much, just because it can't change that much, even over a decent period of time. Whereas your demand for pizza from that establishment might change a decent amount, right? You might still eat there if you really liked it, if you thought it was worth it. But again, there's other places you can get pizza. There's other places you can eat lunch. There are substitutes for eating pizza from that establishment and paying the higher price. And so my guess is some people would substitute away. The difference here is that quantity demanded in both of these cases would probably go down, but they would probably go down by different amounts. Okay, and that concept of precision, of adding precision to our concept of law of demand, is what's called the price elasticity of demand. The answers to both of these questions would depend on the price elasticity of demand. Again, the demand curve for pizza might look something like this, a little bit flatter. You get a price increase, you're going to have a substantial decrease in quantity demanded, which the law of demand says you would. The demand for gasoline probably looks something more like this, a little bit more vertical. Okay, a little bit more up and down. Therefore, you have the same price increase. Okay, you're going to get a drop in quantity demanded according to the law of demand, but it's going to be much smaller, as you can see here. That difference between this gap and this gap is basically we can find that difference using what's called the price elasticity of demand, or the concept of elasticity. The basic idea of elasticity is that it measures how one variable responds to changes in another variable, or I should say how changes in one variable respond to changes in another variable. Okay, and we're going to be specifically looking at how quantity demanded responds or changes, how consumers change their buying habits as various factors that influence quantity demanded change. So we're going to mainly look at how price changes impact quantity demanded. That's going to be our price elasticity of demand, but we're also going to look at income changes and cross price elasticities. We'll look a little bit at the price elasticity of supply as well. But the main concept we're going to look at, and that you need to know for Chapter 5, is the price elasticity of demand. Again, it measures how much quantity demanded responds to changes in price. It's calculated as the percent change in quantity demanded in the numerator divided by the percent change in price in the denominator. Okay, loosely speaking, it measures how sensitive buyers are to changes in price. So if we want to practice with the formula, let's just say we start at a starting point here on our demand curve, and let's just say price goes up by 10%. Okay, and that causes a 15% reduction in quantity demanded. Well, think about our formula. That would give us 15% in the numerator, 10% in the denominator. Okay, if we divide that out, that would give us an elasticity of 1.5, and that 1.5 means something in terms of how sensitive buyers are. It actually means that buyers aren't super sensitive. It doesn't mean that they're not sensitive. It just means that they're not super sensitive. It's very close to 1. Okay, which we'll talk about more in a second. But also we need to know that there's no units with this. Okay, it's not $1.5, it's not 1.5%. Okay, but the elasticity here is just 1.5. Okay, and that's how we say it, that's how we record it. Okay. Now you'll notice that if you were paying attention, right? I mean, that elasticity should have been negative, right? Because we had a 10% increase in price and a 15% reduction in quantity. Therefore, that 1.5 should have been negative. In this chapter, though, we're going to always take the absolute value. Drop the minus sign of any of our calculations. We're just going to be dealing with positive elasticities. That's going to make the interpretation a little bit easier for us. Okay, so just remember to drop the negative if you ever end up with a negative in our calculations in Chapter 5. Okay, something else that can be a concern in these calculations is how do we calculate the percent changes? Okay, I want you to think about a percent change from 10 to 15, right? If I give you this demand curve and the price goes from 10 to 15 and I ask you to calculate a percent change, how would you do it? Well, you'd probably do something like this. You'd do 15 minus 10 divided by 10. 10's the starting point, and so you would get 50%, 0.5 or 50%. And that would not be wrong. But what if we reversed it? What if I said we started at 15 and we ended up at 10, right? How would you calculate over the same section of demand curve using the same numbers? What percent change would you get there? Well, you'd probably get 5 over 15, which would give you 33%. So notice, depending on my starting point and end point, I would actually end up with vastly different percent changes even over the same section of demand curve. That's not going to be very useful for us in calculating these elasticities, so we need something more stable. So we're going to use what's called the midpoint method to calculate our percent changes. Basically what this means is we're going to start with using an ending value, subtracting the starting value, and we're going to divide by the average or the midpoint of those numbers. So for 10 and 15, what we would do is we would do 15 minus 10 divided by 12.5, or the average between those two numbers. Then multiply that by 100%. Okay? The midpoint, and here's a key point. It does not matter which of these which number you use as your end value or your start value, because you're gonna drop the negative anyway. It doesn't matter. You're gonna end up with the exact same answer no matter what number is your end value or what number is your starting value. The key here is to divide by the midpoint between the two numbers. Okay, so let's practice it with some hotel rooms. At the price of $70, the quantity demanded for hotel rooms is 5,000 units. When the price rises to $90, there are only 3,000 hotel rooms demanded. Okay, so remember, the price elasticity of demand is the percent change in quantity demanded divided by the percent change in price. We want an elasticity. How am I going to calculate the percent change of quantity demanded? Right? I'm going to always take the larger number. Again, it doesn't matter which is your starting point, but if you start with the larger number, you'll always end up with the positive. Okay, so I'm going to start with 5,000. I'm going to subtract 3,000, and then I'm going to divide by the midpoint between those two numbers. Okay, the midpoint is just the average. So 5,000 plus 3,000 divided by 2 is 8,000 divided by 2, or 4,000. Okay, so I'm going to take 5,000 minus 3,000 divided by 4,000. Let's put that in a formula. Okay, so 5,000 minus 3,000 quantity demanded divided by the midpoint, which is 4,000, would give you 0.5 times 100 would give you 50%. What about the prices? It's 90 minus 70 divided by the midpoint, which would be 90 plus 70 divided by 2, or 160 divided by 2, or 80. So 90 minus 70 divided by 80, which is the midpoint, or 0.25 times 100 would be 25%. Now, we're not done. That's not our elasticity. These are our percent changes. So how do we find the elasticity? Well, it would be the percent change in quantity demanded, 50%, divided by the percent change in price, 25%, or 50 over 25, which would be an elasticity of 2. Okay, that would be our elasticity. Okay, there's going to be a range of interpretations of those numbers. Okay, let's start with one end of the spectrum, which would be perfectly inelastic demand. This is an extreme case. It doesn't apply in most real world scenarios, but if we had a perfectly vertical demand curve, okay, where any change in price, let's say a 10% drop in price, would not give us any change in quantity demanded because we have a vertical demand curve, right? Then we would have 0 divided by 10%, which would give us an elasticity, right, of 0. This would mean that buyers are not at all sensitive. There's no price sensitivity for consumers for this particular product or service. Okay, that's perfectly inelastic demand. Okay, a little bit more realistic scenario would be an inelastic demand curve, where a 10% drop in price would lead to a less than 10% okay, drop increase in quantity demanded. So a 10% reduction in price would lead, if it leads to a less than 10% increase in quantity demanded, this would be this number in the numerator would be smaller than 10, and the denominator would be 10. Obviously, we would get an elasticity of less than 1. This would be like 0.1, 0.2, 0.5. Okay, this would indicate that buyers have a relatively low price sensitivity to price changes in this market, and it would give us a relatively steep demand curve. This is inelastic demand. This is things like necessities. Things like insulin, if you're diabetic, would have a relatively inelastic demand. Things like gasoline would have relatively inelastic demand. Okay, then you would have another case would be unit elastic. This is a special case where the price change exactly equals the quantity change. So a 10% reduction in price would lead to a 10% increase in quantity demanded. This would give us an elasticity exactly equal to 1. This is just an intermediate price sensitivity, and it just is called unit elastic demand. Okay. Then there's another popular case where a 10% reduction in price would lead to a greater than 10% change or increase in quantity demanded. This is a case where consumers are very price sensitive, and it leads to an elasticity, right? The numerator is bigger than the denominator, so the elasticity would be greater than 1. It would be 1.5, 2, 10, 50, and the larger the number, okay, means the more elastic the demand curve is, which means the higher the sensitivity to prices. Things like luxuries would fall into this category. Okay, things like going on a cruise would be a luxury, and even small price changes in cruise fares can lead to vastly wild swings in changes in quantity demanded because it's a luxury. You would also expect things like eating out. Small price changes in eating out would vastly change consumer preferences and consumer consumption because of sensitivity. Okay, this is elastic demand, and it leads to a relatively flat demand curve here. Okay, and an elasticity larger than 1. Then you have another extreme case, our last case, and this is perfectly elastic demand. This is a perfectly horizontal demand curve where any change, okay, in quantity demanded does not change the price. Okay, and think about it. This is an extreme case where as quantity demanded changes infinitely, the price does not change. Okay, this is an extreme case. This is extreme price sensitivity. It leads to an infinite elasticity. Most categories, most markets don't fall into this category, but we have seen this kind of demand curve before. Remember from chapter 14, we saw perfectly horizontal demand curves for our perfectly competitive firm. Remember that our competitive firm, like a farmer, could increase output any amount or decrease output, and that would not change the market price. This is one application of a perfectly elastic demand curve. Is our perfectly competitive firm from chapter 14. Okay, and so some rules of thumb to help you remember elasticities is the steeper the demand curve. Okay, so something like this: the steeper the demand curve is, the more vertical it is, the smaller the elasticity is. Therefore, the more inelastic it is. Okay, steeper and smaller steeper curves lead to smaller elasticities, which means inelastic demand. Consumers are not very price sensitive when there's inelastic demand. On the flip side, when you have a flatter demand curve, there's a more fantastic elasticity or larger elasticity, right? Flatter and fantastic. Okay, fantastic meaning larger. So the flatter the demand curve, the larger the elasticity would tend to be, which means the more elastic the demand would tend to be. That meaning simply that flatter demand curves are situations where buyers are more price sensitive or have more elastic demand.